Yes, good evening, Emily.
Good evening to you, sir.
Yes, how are you?
I'm fine, thank you, sir.
Okay, let us begin straight away.
Okay.
So with the sequences and series, so we majorly build on the knowledge we get in primary of adding what numbers follow next to a certain sequence. So for example, here we have 5,000 to 10,000 to 20,000 to 40. Okay. So we 5,000, 10,000, 20,000, 40,000. So what do you think would be the next number? Emilia, unmute and speak. What do you think would be the next number?
I think the next number would be 70,000.
70.
Yes.
Let me see. So from 50,000, okay, 5,000 to 10,000. So what do you think has been? They added?
5,000.
Then 10,000 to 20,000.
10,000 was added.
Then 20,000 to, okay, I see. But the most appropriate one would be that to get 10,000 we multiply 5,000 by 2.
Okay.
Then 10,000 we multiply it by 2 to get 20,000. Then 20,000 we multiply by 2 to get 40,000. So to get the next number, we are going to multiply 40,000 by 2, and that will give us 80,000. Okay, then we have this second one. So from 8, we are going to 0, going to 10, going to 10, going to 10, going to 10, then 12, 8, 0. So what do you think could be the next number?
So I don't get that one.
Yes?
I don't get it.
As your homework.
Okay. Let me copy.
You can as well add number 3 to your homework list.
Okay. That in number 3 after 0, is it negative 35?
No, 3.5.
So I've finished.
Okay, then we do number 4 together. 20 to 40 to 60, 80, 100. So what are they adding?
Yeah, they're adding 20.
20. So on 100 we shall add there.
100.
So it will be 120.
Yeah.
So we are saying when we go to the definitions, you first unmute your microphone briefly because it's producing some echo. So on the definition, we are saying a sequence is a set of numbers in a given order, like what we have seen in the order above. So that is a sequence. And we are saying each of these numbers is called a term of the sequence. So if we go back briefly, so here, this one is a term, this one is another term, the third term, the fourth term, and onwards. So this is the first term, so later we shall see how we denote them when we come to specifically the arithmetic progression and geometric progression, where we have the first term and then the corresponding other terms. So we are saying when writing terms of a sequence algebraically, it is usual to denote the position of any term in the sequence by a subscript. So the general formula may be written, so I'm going to write these ones. Let me cross over to the whiteboard. So describing so we have seen that a sequence is a set of numbers written in an ordered pair. So there are of two types. So we are going to begin with arithmetic. Progression. And in most cases, we abbreviate it as an AP. So in this progression, so we are going to begin examples, then we shall see the common, what is common among them. Okay, so when we look at these three sequences, what is common about them? What do they share in common? When you look at them critically.
multiples of 2. Then for here they are multiples of 4. Then the third one they are multiples of 3.
Okay. So do they have something in common?
Maybe for the first and second. Like for the first and second sequences, like to go to the next one, they added 2. Then for the third one, they added 3.
Okay. So let us see. So here we are going on adding. We added 2 to get the next term, and here we are adding a 4, and then here we are adding a 3. Okay, so the common is that to get the next term we do add, and for example, if we began with 1, when we get 2 plus 4 plus 6 plus 8 plus some other terms that are continuing, okay, 4 minus 2 is the same as 6 minus 4 is the same as 8 minus 6, and the answer is
2.
So this 2 is we call it the common difference. Because when we get 4 minus 2, it is the same as 6 minus 4, and it is the same as 6 minus 8, 8 minus 6. So we are calling that a common difference because it is common when we subtract any two corresponding values, it keeps on giving us the same figure. So we call that a common difference. Then this term here, this first term, we are going to abbreviate it as A, and its name is the first term. So where we meet an A, that is how we shall be abbreviating. Is that okay? So it's a network issue.
Excuse me, I'm not getting you very well.
I'm saying it was network. The network is somehow disturbing on my side, but I think we shall maneuver. So we were on the sequences. So we can go to our number 2, which was 4 plus 8 plus 12 plus 16 plus onwards. So here our first term is 4, which is A. Then our D would be the same as 8 minus 4, all 12 minus 8, or 16 minus 12, and that would give us okay. Let me pray hard. This internet will allow us to continue. So we are on 4 plus 8 plus 12 plus 16 plus some other continuing numbers. So we are saying our A is the first term, and that is 4. Then our D, which is the common difference, is 8 minus 4. Or somebody can say it is 12 minus 8, as long as you get any two consecutive numbers and you subtract them, so they give you the same value. So our common difference will still be a what? Will be a 4. Then if we get to number 3, which was 3 plus 6 plus 9 plus 12 plus other terms. So what would be our A?
3 is the A.
3 is the A. And what would be the D?
The D is also 3.
3. So which is got by subtracting 6 from 3. And that would give us 3. Okay? So if we wanted to get other terms, so we would come and add here a 3. So this would be 15. Then we add another 3. It would give us 18.
18.
Is that okay?
Yes, it's okay.
Okay, so now let us proceed and build some few formulas here. Because we have seen it is easier for us to get the corresponding terms that are next, but we might be asked to find the 50th term, the 20th term, and we do not need to write all of them. So we would need a formula where we would substitute and find the values. So supposing I'm beginning by drawing a simple table. Okay. So I have here a position of the term. So this P standing for position. Then we have value. So we shall have first, second, third, fourth, fifth, maybe 10th, and the nth value. Okay, so supposing our first term is A, and our common difference is D. Okay, So here on the first term would have this as A. So what would be our second term?
So I can't see the screen.
You can't see the screen. I think
Yes.
is it network? You are using the phone, eh?
Oh, yes, I'm using the phone.
You are using the phone. You maybe first do what? First leave the meeting and join again, and we see whether you'll be able to see the screen.
Okay, sir.
So are you able to see it now?
Yes, teacher, I can see the screen.
Okay, thank you. That is good. So we are saying our first term will be A. So to get the second term, we get A plus the common difference. So this will be A plus D. Are we there?
Yes, teacher.
Yes. So now to get the third term, we shall get the second term and we add D. So this will be A plus D plus D. Are we there?
Yes.
Then this will be A plus D plus D plus D. Then this will be A plus D plus D plus D, which was here, and then we add another D. Okay. So for now we can first leave out these two, and then we come here. So this is A plus D. So these will now become two D's. So A plus 2D. What will it be here?
A plus 3D.
A plus 3D. Then here,
A plus 4D.
A plus 4D. So if we can come back slightly to so the first so this is the first term, meaning when we are counting them, here n is 1, here n is 2. If n stands for number of terms, n is 3, n is 4, and n is 5. So what is the relationship between this this n value here and this? What is the relationship between those two?
One.
What could be the relationship between n and this column here? That when n is equal to 1, we have A. When n is 2, we have A plus D. When n is 3, we have A plus 2D. when n is 4, we have a plus 3d. Is there any relationship between the value of n and specifically the d? Because the a is common. Okay, maybe before that. So what do you think will be here on the 10th value?
A plus 9d.
9d. So how do we get the 9d?
You add d 9 times.
You add the d 9 times, but the n is equal to 10. So okay, the relationship there is the n value, we get n minus 1 and then multiply it by d. So for example, here it will be n is 10 minus 1 times d. So that gives us 9 what? 9d. So here still it was 5 minus 1 times d.
Yes.
Yes, here it was 4 minus 1. Here it was 3 minus 1. Here it was 2 minus 1. So what would be the nth value?
Okay.
What would be the nth value?
N minus 1 times d.
N times 1 times d. And this will be the formula that we shall be using. So the nth term is equal to a plus n minus 1 times the what? A d. Is that okay?
Yes, teacher.
Okay, so we can proceed and do some examples. Okay, so let us begin with our number 1, which was 2 plus 4 plus 6 plus 8 plus other terms. So we are going to find number 1, the 10th term, number 2, the 19th. Do you have a calculator near you? Yes?
Let me pick the calc, sir.
Okay. So our solution, so when we begin with the Roman 1, so we need the 10th term. So this means n will be equal to 10 because we shall have n number of what? Of terms. So we get our formula that nth term is equal to a plus n minus 1 times d. So we shall say 10th term is equal to a. So what will be our a?
Our A is 2.
2 plus 10 minus 1 times d. What is the d?
D is also 2.
The d is 2. So this will equal to 2 plus 9 times 2. This one we might not need a calculator. This is 18. The answer will be 20. The 10th term will be 20. Then number 2, we're interested in getting the 19th term. So our n is going to be equal to 19. So that means our 19th term will be a, which is 2 plus 19 minus 1 times 2. So 2 plus 18 times 2. What is 18 times 2?